All right. So today we're going to introduce nothing new. We're just going to make this process take even more time. Thanks for that good attitude. I heard that. Great. No, I heard it. You said great. Too late. All right. Please just work with me and we'll be fine. All right. If you look at this screen, it's asking you how many grams of CO2 come from the combustion of 105 grams of this. When we do these problems, if it's written like that, we are assuming that we have that many grams of C4H10 and that we have an unlimited supply of oxygen, which we do. We're just burning this in the atmosphere and oxygen's just around us, right? But most of the time in chemistry, you are given an amount of the first, an amount of the second, and you're asked to solve for what you can get out of that. What this concept is called is limiting reactant stoichiometry, and it involves more time, but pretty much the same processes. So, like, don't give up on me. This is a time where a lot of kids just think, I can't do this class anymore. All right, so here we go. Yeah, it's not that hard. So, like a good infomercial, there's always more. We have been making an assumption the entire time. We have been assuming that we had enough of the other reagent to react with the given. But what if we don't? The answer is it makes it longer. If you're adding notes, this would be your section heading, limiting reactant stoichiometry, or just limiting reactants. And this typically is what some kids consider to be some of the hardest things that we do. This is not that bad if you'll just follow the same process. All right, so here we go. Ever wanted cookies on Sunday and you didn't have enough eggs? Raise your hands if you had that problem. Or any recipe ever. All right, well, then you've experienced the consequences of limiting reactants. If you want to make cookies but you only have one egg and it requires 2, you have to make half the batch. Because you run out of one thing before you can complete the whole thing. All right, ever ran out of gas? Anyone ever ran out of gas? Raise your hands. Besides me. All right. When you run out of gas, you've experienced the consequences of limiting reactants. Gasoline is octane. It reacts with abundant oxygen in the atmosphere to produce CO2 and water. When you run out of gas, the engine stops because your limiting reactant was C8H18. It doesn't matter how much oxygen you have, it's not going to work because this has run out. It limits the amount of product produced. Okay? The limiting reactant limits the amount of products that can be produced. All right, here we go. So, this looks like a nightmare, and it's not the best, but we can do it. So here we go. In these type of problems, you will be given the mass of both of the reactants. You have to be, or you can't do them. So this is just we did it before. It's Na plus Cl2 goes to NaCl. Before we do anything, we always have to balance. So if there's 2 chlorines, chlorines right here. Okay, I put a 2 right there, and then I put a 1. Next step was to find the mass of the 2 things needed. All right, we're actually going to need the mass of all of these, so we might as well. So sodium from the periodic for 1 mole. Chlorine is diatomic, so I have to include the 2. Chlorine is 35.5 times So it is 71 grams per mole. And then NaCl, if you take 23 plus 1 chlorine, you end up getting 58.5 grams. So those are my steps. Now, when we do limiting reactants, we make one here, one here. The pick start with my 2 given reactants, but they both end with one of the products. Now this reaction only has one product, but sometimes when there's more than one, you just choose whichever one you want. Oh, that was dumb. And roll with that. You don't have to do both of them. This is complicated. Just trying to move this out of the way. All right. So both of these picket fences right here, right here. Come on. We're going to solve for grams of NaCl. Both of them. We're doing 2 separate picket fences. Now, listen and just kind of think this through. A minute ago I said that the limiting reactant limits the amount of product that can be produced, correct? So, whichever one of these is the limiting reactant will produce a smaller number than the other one. So, we're going to do 2 picket fences. When we solve for one product, whichever one produces the least, that is my limiting reactant. So, it's the same process. We're doing it twice now. So, one of them I start with 20 grams of Na. The other one I start with 20 grams of Cl2. Then I follow the picket fence process. I take the given and move it down here, grams of Na. Grams are always per 1 mole of the same substance. So then I bring my mole Na down here. And then that's where I get stuck, so I work from reverse. The unit at the end, grams of NaCl. Grams is always per 1 mole NaCl. And then that unit down here goes up there. So I have mole NaCl. Yep. Then I'm going to substitute the gram. We calculated all the grams. They were right here. It was 23 grams of Na. The moles came from the equation, and both of these had a 2 in it. The grams of NaCl were right here. 58. $60.7. Okay. Then I do a second one. I'm still solving for the same product, but I'm starting with a different reactant. So I put grams of Cl2 down here. Grams are always per 1 mole of the same thing. This unit must come down here. Mole Cl2. Then I come to the end, and it's going to match this up here because it's the same thing. So 58.5 grams of NaCl, 1 mole NaCl. And I come up here, there's mole NaCl, and then I just do my 2 NaCls to every 1 Cl2. And then the mass of chlorine we found right here was 71 grams. And then I do this math, and I get what number? 32? Well, round to 33, right? The point of this, find the limiting reactant. And I'm going to pause the video, and we're going to pause for a second. So let's discuss why we did this, and then we're going to cross a lot of stuff out here in a second. So remember, I've said it 2 or 3 times now, the limiting reactant limits the amount of product that can be produced. So the limiting reactant is the one that produces the least amount of product of the two of them. 33 is the smaller of the two numbers, right? Now please look at the screen, because this is super common that you screw up. When kids get this, they're like, oh, cool, NaCl is my limiting reactant. That is not true. This is a product that I started with. Chlorine. All right? So on the test, you're required to identify what is the limiting reactant. So chlorine is the limiting reactant. That's why we did all this math. Now please screen for a second. No. Sodium is going to be called the excess reactant, because it will be left over. The limiting reactant is going to be completely used up to produce this many grams of NaCl.
Okay, that's going to be the small one.
All right, now, how do I know which one it will be? By doing the picket fences. The one that has the smaller answer of the two, whatever you started with, that's your limiting reactant. Okay? So far. Repeat that one more time if you're putting it in your notes. The reactant that produces the smaller number is your limiting reactant. All right, now, my friends, this next part is really important. It's not required on the test or anything, but it will help you to not screw up. Look at the screen. The next thing you should do right now is scribble every single part of this part out. How come?
Because it doesn't count as the excess.
Because it doesn't count. It never happened, because that math would be if it was the limiting reactant. The reason I want you to scribble it out is so you never accidentally use this number, because this number doesn't happen. The only number that really happened was 33. But that's fine. It's up to you whether you want to scribble it out. But I don't want you on a test to accidentally use that number right there. And it happens quite often. Okay. Now, the unfortunate thing is we are still not done with this problem. This problem will require 3 answers. It will ask you what the limiting reactant is, and we know that's Cl2, right? Yeah, it will ask you how much is made. We just said 33, right? But it will also ask how much excess reactant is left over. Now, this can be done in 2 ways. The first way is the easy way, because the second one is the hard way. I'm going to put a little asterisk here. The nice thing about the hard way, well, that's getting worse. The nice thing about the hard way is it will prove to you whether you got the first part right. The easy way assumes that you got the first part 100% correct. And that's fine if you did. But the hard way, when you do it, and we'll do it both to show you what I mean, it will prove whether we were correct in our first assumption. Okay, I'm going to erase all of this because it's super busy, but remember this number 33 real fast, would you? Okay, the easy way is to that the mass of your reactants, the mass of your products. Like everything you start with at the end and everything you start with and you end with, the mass has to stay constant. So what did we start with? 40 grams, which means we have to end with what? 40 grams. But we only produced 33 grams of this, which means I subtract 33 grams, and how much am I left with over here? 7. That's the easy way. Are you okay with that idea though? And look, if you are in crunch time on an exam and you don't have time to do it any other way, do it the easy way and move on. The problem with the easy way is, once again, it's assuming that I got this part perfectly correct, which maybe we did. If you only have 2 reactants, more than 2. So now I'm going to show you the hard way. The hard way is just another picket. It's okay. I didn't know what was going on. Okay, are we ready? So here's the hard way, and it's not that hard, it's just more time consuming. We are going to start with our limiting reactant, and we're going to do a picket fence that solves for our excess reactant. And it will be the excess reactant that is used. If I solve for the excess reactant that is used, I then subtract that from the initial, and that will tell me how much is left over. We'll do it together and it'll click. All right, so what we do, which one was our excess reactant? Or sorry, not our excess. Which one was our limiting reactant? Cl2. So I'm going to do yet another picket fence with Cl2. So 20 grams Cl2. But this picket fence is going to solve for the grams of excess left over, used. And what was the excess reactant? Na. Okay, now, I just do the same process, which most of you are already moving on, which is fine. Grams on the bottom. Grams is always per 1 mole. That means I have mole Cl2 down here. I come over here. My grams are at the end, so my grams are at the end. Grams are always 1 mole of the same thing. And I move that up there. I just fill in numbers. We already have these numbers. They're in your notes. I erased them, but we have them. Just look above on your notes. 23 grams. 1. And a 1 in front of this, right? What, Caitlin? This answer should not be 7. This answer minus 20, or sorry, 20 minus this answer. And bingo, it does, right? Okay, so we now have this picket fence. When we do all this math, it's like 12.96, which I'm going to round to 13. Now, no. Wow, you'll see why. And you're like, oh, this isn't that bad. So remember, solved for the amount of Na that was used. But we're looking for the amount that was left over, right? So what did I have to start with? 20. What did I use? 13. What do I have left over? 7. I've seen that number. And the easy way was 7. I keep kicking that chair. Sorry, folks. Then we know we did every part right. So the 20, I feel like people are wondering where that came from. Seven was the difference between them. What? Is that a frustrated laugh? No, that makes me happy too. That makes me, because these are freaking hard. There's no doubt about it. These are hard. Is there's 40 steps and you miss up one and you're screwed. Yeah, well we have a week from the test. And hopefully chemistry can get good by then. There are 2 tiny little things at the end that aren't that bad. Game. Of course we are. Everyone needs it bad. Okay, here we go. Who said that? Is that sarcasm? That is beautiful, huh? Like, that doesn't like float your chemistry boat right there? So that's like a torpedo into your chemistry boat? Okay, here we go. That girl understands some chemistry. All right, look. This is yeah. The other one didn't have 2 products. Okay, here we go. I'm going to restart this whole problem because I can. Here we go. Silver nitrate plus calcium carbonate produces silver carbonate plus calcium nitrate. The first step would be to write and balance. So there's a 2 in front of the AG, and that is it. Step number 2 is to do what? You're all right in your silence. It's to find the masses of every single thing now, because you're going to need them all. Now, is everyone done writing this? Because they're on the previous page, and let's just look them up. You ready? So, 169 and 100. Yeah, I'm just doing the masses for you to save us some time. 276, 164. These are our grams. We're going to need every single one of them. Now, this problem is different than the last one because it has 2 products. So it's yet another step. On the test, and it's what you guys were asking, like, what the heck is that? You're going to be asked for, oh, this thing's so dumb now. The test is going to ask you to solve and tell me what the limiting reactant is, And then it's going to ask for the grams of every single thing. So grams AgNO3, we're looking for these answers. Grams CaCO3, grams Ag2CO3, and grams CaNO3, 2. So this is what you're going to have to answer on the test. You can't be serious right now. Oh well. You're going to have 4 picket fences. There are ways around it, but I'm not going to teach that yet because those ways have 20 million landmines. Okay, now look real quick. One of these answers right here is always 0. Do you know which one that might be? It's the limiting reactant. So when you find the process of finding the limiting reactant will answer this question, and it will tell you that the limiting reactant is 0. And when you solved for it, you would have solved for one of those too. So you're 3/5 of the way done by doing the first step. Because it's the one that runs out. It's completely consumed, so there's nothing left. We're going to do that right now. Are we ready? Now, to save me some time, I'm going to assign a variable. This is A, this is B, this is C, and this is D. I'm just doing that so when I write my picket fence, I don't have to write that unit every single time. When the units are big, doing that can kind of help. Thanks for checking post. You are a good friend. Oh, never mind. Yeah. Okay, now, some of you might wonder, well, which one of these do I solve for? The answer is it doesn't matter. It doesn't matter. You have to solve for both. But when we do the limiting reactant, we're going to solve for the same one twice, correct? Yes. So here we go. So, part of the problem you don't have yet, we had 10 grams of each one of them. Well, 10 grams of this, 10 grams of this. That's your given. So, I'm going to use calcium because the mass of 100 is easier to do math with. So what I'm going to say, I have 10 grams, and I'm going to call it B, just to save me writing CaCO3 a million times. Are we okay with that? All right. Then I have grams B for every 1 mole of B. Then what must be down here? Mole B. 100 is right, if you were just looking where I was going. Okay, and what are we solving for now? Let's just call it C. You okay with that? We can pick C or D. Because it doesn't matter. We have to solve for both of these. So it doesn't matter if we do C first or D first. No. Time out. We have to start 2 picket fences with B and end both of them for the same thing to find which one's the limiting reactant first. Just keep watching. This is just the limiting reactant step. So here we go. We're solving for grams of C. So I have grams of C for every 1 mole of C. Coming up here, I have moles of C. Then I just substitute the stuff in. The grams of B are 100. The moles of B is a 1, just from here. The mole of C is a 1. The grams of C are 276. And then I do some math. What the heck is that? Yes, the next picket fence has to solve for the same thing. It has to solve for the same thing. These have to be the same each time. Okay, what was the first math answer? Anyone have that? 27 point what? 6. Okay, now the second one, remember? You're still writing. Are we good? Now, I think I said it wrong. This one's going to start with A now. 10 grams of A, but this time we're still solving for C, right? So I have grams of A, mole A. What comes down here? Mole A. Then I come here. What's at the end? Grams of C. Grams are per what? 1 mole of the same thing, so it's C. I come up here, and it's mole of C. Then I plug in the things. A was everything that was over here, so it's 169 for every 1 mole. What's in front of this is a 2. In front of C is a 1. And then 276 is the grams. And I plug this in, and what do I get? 18. Okay, now, one of these two numbers is smaller. It's this one, right? Okay, so maybe you don't want to like totally scribble it way dark out in your notes, but we're going to ignore this one, right? Because this one never actually happened. So here we go. We can answer some things. My limiting reactant, what is its identity? It's whatever A was, which was silver nitrate. Then my mass of silver nitrate then is equal to what? 0, because it's the limiting reactant. And my mass of Ag2CO3 is that answer. Why? Because that's what it is. The limiting reactant produced 8.16 grams of this. That's the mass of C, which we define as Ag2CO. No, not yet. Now we need another picket fence that solves for the amount of my other product. But it has to start with what? My limiting reactant, which we were calling grams of A, right? Yep. No. Okay, we'll pick this up.